Assignment 26, 4.2, derivatives of a product of two functions. Essential question: how do you use the product rule? To find the derivative of the product of two or more functions. Okay, so an example I'm going to come back to. Oops, sorry, my pencil's not working. An example I want to come back to that we're going to actually look at here is how would you take the derivative? So I'll actually write that. How do you find the derivative of, for example, y equals, let's just say 2x plus 5 to the 6th power times 5x minus 2 to the 4th power. So the problem that we're having here is that we've got basically two functions. We have this first binomial to the 6th power, and then 5x minus 2 to the 4th power. We have to take the derivative of those, okay? So far, we've only been doing that if there's like plus signs in between everything. But here I've got actually two functions I need to take the derivative of. Well, there's a fantastic way to do this, and it's quite easy, but you do have to remember how it works, okay? So it is called the product rule. So the product rule states that if, for example, y equals u times v, then y prime, or the derivative of y, is basically going to be u prime times v, or the derivative of u times v, plus u times the derivative of v, or v prime. Okay, and then I'm also going to write this out for you. So I really want you to think about this verbally. This doesn't make as much sense as what I'm about to say verbally. Okay, so, and I'm going to write that in quotes. So the way that we say it is, and I would say this to yourself over and over and over every time you do one of these problems, the derivative of the first, right? So first polynomial, or sorry, first function is going to be u. So I'm going to take the derivative of the first, that gives me my u prime, times the second, so times the second means times that by v, so that's why I did derivative of u, which is the first, times the second, plus the first times the derivative of the second. Okay, so plus the first, which is that u, right? That's my u, times the derivative of the second, which is v prime. Okay, so let's actually do one of these. I don't think I'll start off with this first one here. I think I'll start off with one a little bit easier. Okay, so our example 1 is to find the derivative. Oops, sorry about that. Example 1, find the derivative. Alright, so our first one that we'll do is if I give you the function y equals x cubed times sine of 2x. Okay, so notice that I've got more than one function happening here, right? I've got that x cubed times the sine of 2x. It'd be different if there was just a coefficient out here, but there's not. There's an actual product happening between two functions. Okay, so I could write this as y prime. I could write this as the derivative of y with respect to x, which I think I will do. Okay, so this is where I say this to myself over and over every time I do this. The derivative of the first. So I need to take the derivative of the first function. Okay, so that's going to be 3x squared. Okay, everybody agree? The derivative of x cubed is 3x squared. Okay, go back here, times the second. So now I just multiply it times sine of 2x plus the first. So I'm going to take that first function, which is just x cubed, times the derivative of the second function. So the derivative of the second function will be the cosine of 2x times the derivative of that inside function, which is 2. So yeah, nothing goes away here. So now you're using the product rule and the chain rule. It's all crazy, I know. So when I simplify this, let's say I don't think there's much I can do with my first term here. But I think I'm going to go ahead and bring that 2 out with that x cubed. And there's your derivative. Okay, I'm going to go on to the back because the next problem, which happens to be this one, is going to be quite lengthy. You guys write smaller than I do, but this way I've got lots of room and I can explain things if I need to. So y equals, again, the 2x plus 5, so the 6th power, times 5x minus 2 to the 4th power. Alright, so the derivative of y with respect to x. Alright, so now I have this memorized because I've been doing this long enough. You guys have to continue, and I always say this to myself, okay? So you should be saying it to yourself too. Derivative of the first. Alright, so the first function, and maybe colors would be helpful for you if you needed to, separate this. Maybe this is highlighted yellow and this one's highlighted green or something. But I'm basically going to take the derivative of the first function. So that means the derivative of this, well, first I'm going to use my power rule. And then take the derivative of the inside, which is times the 2. Okay, so that's my derivative of my first. Times the second. So now I just do times 5x, 5x minus 2 to the 4th. Plus, now I'm going to do the first, or that first function that I originally had, times the derivative of the second. So the second function, power rule first, bring down the 4, times the derivative of the inside, so times 5. Okay, so now I go through and I do some simplifying. So let's see, first of all, this is going to be a 12. 2x plus 5 to the 5th times 5x minus 2 to the 4th. Okay, I'm going to do some simplifying over here as well. I see that I have a coefficient of 4 times 5, so that's going to be plus 20 2x plus 5 to the 6th times 5x minus 2 cubed. Okay, now this is where it gets really fun. Factoring. I know you guys all love factoring. So we have two terms here, right? I need to look for greatest common factors in those two terms. So let's see. First of all, starting with 12 and 20. So that means that they would have a greatest common factor of 4. So I'm going to pull out a 4. They also have a 2x plus 5 in common. They have a total of 5 2x plus 5s in common. So I'm going to pull out 5 of those. And they also have a 5x minus 2 in common. And it looks like the most that they have in common are 3 of them. So I'm going to pull out 5x minus 2 to the third. So now the question is, what's left? So I'm going to put that in brackets just so I can start trying to make some sense out of all this. So the question is now, if I take this, what do I need to multiply it by here to get this? Well, it looks like I need a 3. I don't need any more 2x plus 5s, right? I've got 5 there, and I've got 5 here. But I do need one more 5x minus 2, right? Because I need to have 4 there. So it's going to be times 5x minus 2. Okay, so that took care of that first term. Okay, now we need to move to the second term. So this whole thing times what will give you this second term? Well, I'm going to need a 5, so a positive 5. Looks like I'm going to need, I've only got 5 of these 2x plus 5s. I'm going to need one more of those. And I've got the right amount of 5x minus 2s, right? I've got 3 of them, and that's what I need. Okay, from there I'm going to go ahead and simplify what's left in these brackets. And maybe it'll reduce and just be my last factor. So let's see what we've got going on here. Or it'll simplify, it'll squash down. So we have 2x plus 5 to the 5th times 5x minus 2 cubed. Okay, and then in these brackets, let's see, I'm going to have a 15x minus 6 plus 10x plus 25. We can still simplify that. So let's see, I've got 15x and 10x. That's going to give me 25x. And then a negative 6 and a positive 25 is going to give me a positive 19. All right, so I think we've got our entire solution here, our entire derivative. Isn't that fun? Everything you've been preparing yourself for. There it is. Oh, there's a lot more of it. Let's do a couple more. I'll do a couple out of the textbook with you. So how about we go to, let's do number 12. Okay, so number 12 from the textbook. This is going to be on page 134. So similar type of problem. Okay, so you need to think to yourself, right? You need to always be saying this to yourself. Derivative of the first. All right, so p prime of x will equal 4 times the derivative of this first thing is x cubed plus 6 times, we need to do the inside function, right? Don't forget about that. Chain rule never goes away. Times the second. Plus the first times the derivative of the second. So, hold on, my lead is really messing up, sorry. Okay, derivative of the second is going to be 6 times the inside. Then I'm going to multiply that by, oops, to the fifth, sorry. Then I'm going to multiply that by the derivative of the inside, which is times 3x squared. Now it's time to simplify. So let's see, I have a 4, a 3, and an x squared. So that's going to be 12x squared. Oh, I did the same thing here, didn't I? So this should be cubed, right? Because I took down the 4. Hopefully you've already caught that. I'm making these mistakes just for you to help you make sure that you're catching them. All right, so x cubed plus 6 cubed, and then another x cubed plus 4 to the 6th. Now over here it looks like I've got a 6, a 3, and an x squared. So it's going to be 18x squared times x cubed plus 6 to the 4th, and then x cubed plus 4 to the 5th. Now it's time to factor out any greatest common factors. So just looking at these terms, or these factors, I think we're going to have a 6 and an x squared. Okay, and then looking at what other things do these two terms have in common? Well, they've got an x cubed plus 6, and the most that they have in common appears to be cubed. So I'm pulling out an x cubed plus 6 cubed. And then they've also got an x cubed plus 4, and it looks like the most that I can pull out is 5 of them. So now I'll write the remainder of what's left. Okay, so 6x squared times what will give me this 12x squared? Well, I need a 2. How many more x cubes plus 6 do I need? None. But I do need another x cubed plus 4. Now looking at the second term, 6x squared times what gives me that 18x squared? Well, I'm going to need a plus 3. Do I need any more x cubes plus 6? I do. I need one more. Do I need any more x cubes plus 4? I do not. Okay, so now it's time to simplify what I have inside these brackets. So I'm going to have a 2x cubed plus 8 plus 3x cubed plus 18. I'll simplify that one more time to have my last factor. So I end up with 6x squared, x cubed plus 6 cubed, x cubed plus 4 to the 5th, and then here I'm going to end up with a 5x cubed plus 26. There's your final derivative there. I'd like to do one more problem with you. I'd like to do number 20 from the same page. And let me get another sheet of paper. I'm going to use, you know me, I write big, so I'm going to use a lot of space here. So number 20. So you have a function that is u equals 3x to the 5th times x squared minus 4 times cosine of 10x. How many functions do we have here? So I'm hoping that you can see that you're going to have 3 functions here. So what happens if you have 3 functions? So let's see, let's call this function here, we'll call that A. The next function will be B, and the next one's going to be C. So it follows the same pattern, okay? The way that you're going to take the derivative of this is you will do the derivative of the first, or A prime, times the second two, plus the first times the derivative of the second times the third, plus the first times the second times the derivative of a third. So you could do this for any number of functions, right? I mean, who knows, just for fun, we could do one with 10 different functions. It would take forever and we'd need a lot more paper. We'd probably just want to do that on a whiteboard. All right, so let's do this. So I'm going to take the derivative of u with respect to x. So that means I need to take the derivative of the first function, which would end up giving me 15x to the fourth, times the second, which is x squared minus 4, times the third, cosine 10x. Okay, now I'm on to the second piece. So now this is where the second piece gets differentiated. Okay, so I'm going to keep the first. So I'm going to add 3x to the fifth. Now times the derivative of the second. So I'm really just going to do 2x and I don't need to take the derivative of a third yet. Now is the time for the derivative of the third. So now I'm going to add. Okay, keep the first. Maybe I'm going to go down here. Keep the second. Derivative of the third. So derivative of cosine is negative sine, I'm going to put a times there, of 10x times the derivative of the inside, which is 10. Time to simplify. So let's see. In this first piece, I don't think I have anything really to simplify. Okay. In the second piece, I can multiply the 3x to the fifth and the 2x. So that's going to give me a positive 6x to the sixth cosine of 10x. And in this last piece, it looks like I have a 3x to the fifth, a negative 1, and a positive 10. So it's going to end up giving me, let's see, and I'll bring it down here, negative 30 x to the fifth, keep my x squared minus 4, times sine of 10x. So now looking at my terms, so now I've got 3 terms. And now my question is, what do we have in common? Well, I can see that there's a 3 and an x to the fourth in common. They do not happen to have an x squared minus 4 in common. That's not the same throughout. Same with the cosine or the sine. So really that's all I can factor out. So at this point, this is an okay answer. Because there's not too much in common. There's not too much that can really be done with that. However, let's go ahead and just finish this since I've started it. 3x to the fourth, so I'm still going to have an 5x squared minus 4 cosine 10x. I'm going to have a 2x squared cosine 10x. And I'm going to have a negative 10x x squared minus 4 sine of 10x. Okay, so either one of these is a good answer. And it really depends on what you're doing with it. If you needed to be able to simplify something out, reduce it with something maybe in a denominator, then this would be really helpful.